This will be lesson 2 of chapter 3, and in this lesson we'll talk about some of the numbers used on the periodic table for the elements. The first number we'll introduce is the atomic number. Now the atomic number, symbolized by the letter Z, after yours truly, is the number of protons in the nucleus, and it identifies the element. By this we mean if you know the number of protons, then you know what kind of element you have. In fact, lithium, for example, has 3 protons in the nucleus, and only the element lithium has 3 protons. No other element has this many protons. 29 would be for a totally different element, in this case copper. And we can use the periodic table to find out exactly how many protons, and it is this number, usually the whole number above the element is the number of protons. The periodic table has a bunch of different elements, and we'll study a lot of them in depth, but notice each element has a unique number above it, and that is how many protons. This is called the atomic number. Your key on your periodic table also has this. This is the atomic number, the number that tells you which atom you have. Now it's important to say that all atoms have the same number of electrons as they have protons. Remember that electrons are negative and they exist on the outside of the atom. Protons are positive. So if you're an atom, you are neutral. Neutral meaning you have to have the same number of positives as you have negatives. In this case, this is an atom of beryllium, 4 protons, 4 electrons. It has no charge. So we can ask a question like this: how many electrons and protons does an atom of silver have? If you find silver on the periodic table, Ag is the symbol for silver, and 47 is the number above silver. This whole number is the atomic number. This is how many protons silver has. So silver has 47 protons. Electrons is the same as protons for an atom, because atoms are neutral. So you'll also have 47 electrons. So pretty simple answer. Nothing mysterious here. The number at the top tells you the proton count. Try this example on your own. Pause the video as needed. Let's talk about something called an ion. If an element gains or loses electrons, we call it an ion. And most of the elements actually exist in this form, in the ionic form. So here we have sodium, the element sodium, Na, losing an electron. Now because electrons are negative, here we're representing an electron with a little minus sign at the edge. And when you remove a negative, what you'll get is you'll get yourself a positive. And this is called your charge. And the charge is actually written to the upper right-hand corner of the symbol, always, as in the case of sodium. Now you can put just a plus, or you can put a +1. If it's 1, we'll sometimes leave the 1 off. But any time above, if it's above 1, we'll have to include the numbers. So here's kind of the rule. If an atom gains electrons, it becomes negative. Whoops. This should be backwards. Let's apologize. There actually is a little typo here. If it loses, it becomes positive. And if it gains, it becomes negative. Go ahead and change that in your notes accordingly. I apologize for that. So losing electrons makes the atom positive because negatives have been taken away from it. Think of it this way. Gaining electrons make it negative because electrons themselves are negative, and if you put more negative on an atom, like in the case of oxygen, you will become negative. So this sometimes sounds backwards, especially in the case of losing electrons, but that's because electrons are negative. You remove a negative away from sodium, and you get yourself a positive ion to come out of it. So we're actually going to do an example, just so we reiterate this idea. So take a look at this example, 3. Write an ion of nitrogen which has gained 3 electrons. Now what you'll have to find is you'll have to find nitrogen on the periodic table, and nitrogen will have above it the number 7, and this tells you how many protons nitrogen has. Remember, this is the atomic number. So since we have proton count is 7, here it says we have gained 3 electrons, which means our electron count is 10. Now since protons are positive, we have 7 positives and we have 10 negatives. So overall, 7 minus 10, essentially is what we're doing, 7 minus 10, we'll get -3. And this -3 is the charge that goes on nitrogen. We'll write the symbol for the element, and then the -3 goes in the upper right-hand corner. This is how we write ions. How about for part B, write the ion that has 11 protons and 10 electrons. So find the element which has the number 11 above it, and that element should be Na, the one that we've just seen, sodium. Now because it has 10 electrons, you have proton count is 11, your electron count is 10. Electrons are negative, protons are positive. You've got one extra positive than you have negative. Technically what you're doing is you're doing 11 minus 10. So you got 1, and so sodium's charge would be +1. You can put the 1 in there, or you can just leave it as a plus. Then finally part C says how many electrons does this ion have. Notice that the atom is Ti, which if you take a look at the periodic table is titanium, and titanium has a 22 above it, which means it has 22 protons. Since it has a +4 charge, that means it has 4 more protons than it has electrons. If you have 4 more protons than electrons, then you have 4 less electrons, which means you have 18 electrons. Again, since you have 22 protons, all protons are positive, you have to have 18 electrons, which are negative. To come up with a +4 charge, you have to have 4 more positives than you have negatives. So the answer is 18 electrons. Stop and replay as needed, but let's go on to a discussion of something else. Do this example problem on your own. Stop the video, try this. We're going to finish up talking about what are called isotopes. Now, isotopes are what ions are to electrons. Isotopes are in regard to neutrons. So atoms of the same element that have different numbers of neutrons are called isotopes. The prefix iso actually means the same. So they're the same element, but they have a different number of neutrons. Now, since neutrons, we talked about, have mass, these isotopes will have a different mass. Ions don't really have different masses, but isotopes do. Remember, that's because the electron is really tiny and insignificant, a mass of 0 compared to the neutron, which we said is a mass of 1, and the proton, which is also a mass of 1. So here are 3 different isotopes of the element hydrogen. Now notice all of this is hydrogen because hydrogen is the first element on the periodic table, so you only have 1 proton in each case. But the number of neutrons changes between the isotopes. So all 3 of these are isotopes of hydrogen. This one has 1 neutron, this one has 2 neutrons, and this one has no neutrons. All 3 of them are isotopes because they all have 1 proton, they all refer to hydrogen. We're going to define some numbers that relate protons and neutrons. The first one will be the mass number. The mass number is the total number of protons and neutrons in the nucleus. Remember, that's where protons and neutrons reside, and the mass number tells you what type of isotope you have. So here now is a sodium isotope, and the 23, this number, is the mass number. And again, it's called the mass number because the 2 particles, protons and neutrons, are the massive particles. They are the particles that have mass, so we put them together and get the total mass of this isotope, which is 23. Incidentally, the number 11 at the bottom is again the atomic number, which means, remember, is the number of protons in the nucleus. And this is the number that shows up on the periodic table. Above sodium, you have an 11 on the periodic table. Sometimes the atomic number is left off, and the reason for this is because no other element can have 11 protons. So you don't need to say that it has 11 protons. Sodium must have 11 protons. There are 2 different ways for writing these isotopes, and we'll show you both of them, and we'll do an example of each. So you can use what's called the hyphen notation, in which you spell out the whole element name and then put a hyphen. This is what we mean by a hyphen. And then your number, which is, remember, the mass number, protons plus neutrons. And the nuclear symbol notation, which simply shows the symbol, not the whole element written out, just the symbol. And the mass number goes at the top. And again, this is the atomic number, how many protons it has. Sometimes we can leave this number off. So why not we try an example? And the first example says, how many neutrons do we have in chlorine 37? Well, this, remember, is the mass number, and this mass number has protons plus neutrons. So if you can find out how many protons chlorine has, we'll subtract away to find the neutrons. So for chlorine, if you take a look at the periodic table, you'll see that there's a 17 above chlorine, which means chlorine has 17 protons. Since it has 17 protons, our total is 37. So 37 minus 17 leaves us with 20 neutrons. And this is the answer. Again, because this number is simply the total of protons and neutrons. Subtract away the protons, you get the neutrons. How about write the isotope that has 35 protons and 40 neutrons? So we're given 35 protons, which means we can identify the element. If you find on the periodic table the element with the 35 above it, you'll find it is iodine. So we're dealing with, I'm sorry, not iodine, it is bromine. Let's try that again. This is bromine, iodine is right above it. So we are dealing with the element bromine. So let's go ahead and write bromine, hyphen, and then in here goes the total of the protons and the neutrons. So we'll have to add 35 and 40, which should be 75. So we have bromine 75 for our isotope. You can also write this as Br 75 using nuclear symbol notation. And if needed, you can put the 35 down at the bottom. So this would be nuclear symbol notation. Look over this video again as needed. We went a little quick through it. Try the practice problems yourself. In fact, there's one more practice problem for you to try as we wrap up. And then we'll practice a lot of this sort of thing in class as well. Hope you enjoyed the video.